Hello, colleagues. I welcome you to the second aspect of the stochastic frontier analysis. Let us not forget we are considering the case of panel data, and the data we are using is rice production in Philippines. So let's run our data set up to that so that we don't miss anything. Okay, we've done it up to this missing value graph. Run. Yeah, and let us not forget this, our missing value graph. So in case we want to get the descriptive statistics, then we use prepare underscore descriptive on the table, then the name of our data set. So let's run it. So here we are. Then in order to get our results, so we say this is the name here, then dollar cable rates, then percent greater percent cable styling, then we condense full width equals to false, then we use center position. So center position so that we see it clearly. So let's run this. So let's refresh our viewer. So this is the result. And we can show this in a new window in a clearer form. So this is the results. And let's say select all. Let's copy the results. And you can take the results to Word. Okay, let's use this. Yeah, so straightforward. So, and you can make necessary adjustments to your table if you so desire. Okay, if you want to do that, you click here, then you see table design. So you can design your table the way you like. So let's go back to our R. So another thing we can do, we can draw a group bar graph. Let's say we want to prepare the group bar graph by of a variable, let's say by year. Let's pick production, and let us get the mean for production, and we now say order by start equals to true. So let's run this. Yeah, so and this is the graph. Now you want to export it, you just click on export, copy to clipboard, then you place it in Word documents. And we can prepare trend graph also. This for our year, then for, let's say we are considering production and area, we can get as many variables as possible. But we have to be sure of the measurements so that we can see clearly our line graphs. So let's run this. Yeah, this is a typical example of what we are saying. Let me get the zoom so that we can see it in a clearer form. Yeah, this is area, this is production. Yeah, so you must first try as much as possible to look at those descriptive statistics. So after you have done that, then we now estimate our error component frontier. That is, we ignore the panel structure. We're looking at the observation specific efficiencies, just like as if we're running the normal error components like before, ignoring the panel structure. So if you want to do that, just like what we've done, let's call that one rise, SFA. This is log area, log labor, log, and so on. So in this case, our interest is just the observation specific efficiencies. The panel structures, it's not a concern. We are not concerned with individual fixed effects. We are not considering the time fixed effect and so on. So if that is what we want to do, let's run it. Yeah. Okay, so here we are. In that wise, our overall mean efficiency is 0.82, and we can get the efficiency scores for every observation. I think there are 344 in this situation. So we want to do that. That's what I have here. Again, you use frontier efficiencies. But now you will have to include this as in data equals to true. Remember, so that because we are just as it is in the data, so that it's going to consider it 1111 2222 and just the way it appears in the data sets. So let's run this and be sure of the results. Yeah, so the result is out. Another one we can do is a situation whereby we want to consider the individual fixed effects as well as the observation specific efficiencies. So if that is what we want to do, that is what I called rise through here. And the difference between that and what we've done is to include the variable representing the cross section. So it's like we are now including the domain for the number of farmers. So here we have FMR code, but we put factors so that it's going to include it as factors. So let's run it and get the summary. Um, Run. Yeah, here we see it's going to give us the efficiency for different. These are the efficiency scores. The efficiency scores for um, each farmer over the 8 years. Yeah, and that is very, very important. Yeah, and this is the mean efficiency overall. So, but another thing we can consider is time variance efficiencies. In this case, we want to consider the time effects. The other one is time invariance. So now we want to consider time variance efficiency model. So I call it rise time var. So we run it like before, but now you include time effect is equal to true. And let us run it and we get the results out. Yeah. So this is telling us the mean efficiency of each year. We have 8 years. And this is the overall efficiency, still the overall efficiency. So, and now we've discussed this, and you can see the time effects. Yeah. And we can compare some of these results. Let's say we want to consider rise and rise true. We use our likelihood ratio test. Um, yeah, and our interest should be the whether this whether our p our chi-square is statistically significant, and it's very very highly significant, showing us clearly that the two models are different. Yeah, but like before, in case we want to include the inefficiency variables, yeah, just this perpendicular sign here. Then we include the inefficiency. Let's say we include education, then balance. So if that is what we're trying to do, then let's run this. Yeah, good. So we can now see um can see the differences actually. You can compare the efficiencies for various years when the inefficiency variables are included and when they are not there, and the overall mean and so on. So, and even when we are dealing with technical efficiency, we can have the model with intercept and we can have the model without intercepts. If you want to have the model without intercepts in your inefficiency variables section, you will add -1. -1. Yeah. Okay. Let's run this. Yeah, you can see some differences. And we've just done this thing mechanically. For details of the explanation, the theory itself, the equations, I sent a book to you, Production and Efficiency Analysis using R. I advise that you go through the book. There is another one. If I can lay my hands on it too, maybe I have to send it. It's by William Green, Econometrics of Production Efficiency Analysis. So you go through some of these books because everything I just want to show here is how to do the estimation. And I would be glad if you can go through this, compile your questions so that by the time we meet um, tomorrow, we'll be able to look more into some of these questions rather than uh, taking more time to look at all these things. So that specifically we'll be looking at some of the questions and we have more time um, to learn more. So thank you. Um, I still have one other video to send to you, which is on DEA, the estimation of the technical efficiency. Thank you, and thank you again.